Hey there, this is Seth Warris from Channel 9 coming to you from Building 17. I almost
17.
said 16.
Yep.
With the awesome Anders Hejlsberg. We are here to talk about TypeScript and the future of TypeScript. So tell us a little bit of the history of TypeScript, very digest form for those that still are living under a rock and don't know about it.
Sure.
And then let's talk about some of the challenges that you're facing and then how we're going to fix those in the next version.
So the TypeScript project is about, well, it's about 4 years old.
Yeah.
I guess we launched in October of 2012. It's an open source project, and it's all about making JavaScript scale. So about helping you build large JavaScript apps, and it has basically a compiler that where you can add, it's a superset of JavaScript where you can add type annotations, and then we have a tool set that can check these type annotations for you and give you statement completion and all sorts of good help as you're authoring. But then when we compile, it goes back to JavaScript. So that gives you better tooling. And then in addition, we can also down-level compile your code, because if you think there's a feature gap in JavaScript, and that feature gap has been there for a long time, it's probably always be there.
Yeah.
Meaning that there's the latest and greatest that's been defined for the language, called today ECMAScript 6 or ECMAScript 2015. But of course, there are also a bunch of old browsers on your old phones that don't support that flavor of the language yet. And there's a many-year gap between the tail and the front. And, developers want to be at the front.
Right.
But code needs to run on the tail. And something needs to fill that gap. And you can do that by transpiling the code down to a down level. So a lot of these new features that are in ECMAScript, like classes and modules and whatever, you can actually down level transpile into patterns that exist on the older runtimes. And that's a thing that TypeScript does also. So those are sort of the two things that we do. We do excellent tooling powered by static types, and then we fill the JavaScript feature gap.
And that feature gap, when you're using a module or a class, is semantically equivalent to what it down transpiles to.
Yeah, but it's just much nicer syntax. It's a heck of a lot nicer to write class foo instead of some immediately executing function with some prototype assignments and what have you, right?
My first experience with JavaScript was literally an image rollover when I was like 15 years old. And now you're writing tooling like Visual Studio Code, which is effectively in JavaScript.
It's written in Type. Visual Studio Code is all written in
TypeScript. But if it was written in JavaScript, it would be absolutely difficult.
It's mind-bogglingly difficult to work on large JavaScript code bases, in particular if you have teams with multiple members and new members coming in and so forth, because if you have 100,000 lines of JavaScript code and you need to refactor something, how do you do that safely? It's just, and so JavaScript code sort of turns into read-only code eventually, and people just hack on it and whatever, and this is basically a way to help with that.
So TypeScript is keeping pace with the current sort of novelties or new things in JavaScript or ECMAScript. What are some things that we're looking forward to in the next version of TypeScript that maybe you could talk about or preview?
Sure. Well, so the next version of TypeScript is TypeScript 2.0, which is due out sometime later this year, in the not too distant future. Some of the headliners there are support for async await down level. We do support it today, but only if your target is ECMAScript 6, and now we're going to be able to down level that. We have better support for acquiring type definition files, and which is the way that people write down their type definitions for JavaScript frameworks. And then we've worked on supporting non-nullable types and control flow based type analysis, and that also gets us to a point where we can address Hoare's $1 billion mistake, the null, which actually in JavaScript, interestingly, JavaScript has the $2 billion mistakes, null and undefined, because there are two nulls in JavaScript, because if because if one is good, then two's better, right?
Yeah. So let's go through each one of these things really quickly, and then let's get into this. How do you fix the null problem?
Okay.
So async await.
Yeah.
I know that we support it because I talked to someone that works on the Edge browser, and they did some magic C++ code that they call into. But how do you fix that?
Well, I mean, so async await is a feature that is slated for inclusion in ECMAScript. It didn't make it into ECMAScript 2015, but hopefully it'll make it into one of the next ones.
Right.
But there's a fairly complete proposal for it. And the trick with async await is that it requires you to do some pretty hairy rewrites if you don't have generators. You basically have to build state machines when you're transforming async await into non-async await code. Now ECMAScript supports, in ECMAScript 6, supports generators, and generators make it easy to implement state machines. And so you can transpile it to that pretty easily. But if you're transpiling down to ECMAScript 5 or ECMAScript 3, which is what phones typically run, then you need a more complex transformation, and that has taken a while for us to build in the emitter, but that's what we're in the final throes of doing right now.
And that, I mean, it just boggles the mind because, I mean, I struggle at times understanding fully what async await is doing in the background because there's a complex state machine that's waiting for things and moving things around. But in JavaScript, it's got to be even harder because you don't have control of what the computer is executing. You only have control over what the computer can understand with regards to JavaScript, right?
Yeah, I mean, I think if you think about like JavaScript code, in JavaScript you end up writing lots and lots of callbacks. I don't know if you've ever written
with promises,
like
right?
event handlers. Yeah. Well, you can turn it into promises, but it's still callbacks. That's sort of callbacks in a different guise, right? You still have to write all of these functions that then get called back later when the result is available. And that has a way of sort of turning your code inside out. And now if you need to write a loop around something that executes callback style, it's like, oh my God, how do I even do that?
Yeah.
But with async await, you basically get to write your code as if it is normal sequential code. And then we turn it into callback style by doing rewriting of the code. And it uses promises to actually as an implementation mechanism. So it's compatible with the new promises that are already in ECMAScript 6. So yeah.
Okay, so that, I mean, it's even if you don't understand how it works in the background, you get the promise of async and await in JavaScript and TypeScript that then will do the right thing in whatever flavor of JavaScript that's running.
Sure.
So the next one you said was type definitions.
Right.
Tell us about that. For those that don't know what type definitions are and they're just barely getting started with TypeScript, what's in those files?
Sure.
And then what optimizations are you doing?
So when you're using TypeScript with existing JavaScript frameworks, unless you give us some information that tells us what's in the framework, we can't really do a whole lot for you. But if you give us the type definitions for the framework, which you can write down in a separate file called a d.ts file, then we can use that information when we analyze your code, and we can use it to serve up statement completion and help
and description
and et cetera. Yeah. However, you somehow need to acquire these type declarations into your project. Say you're working with jQuery, you need one for jQuery. If you're working with Lodash, you need one for that. If you're Angular, et cetera, right? So the community has been gathering all these type definitions in a GitHub site called Definitely Typed.
Yeah.
There's I think we're close to 2,000 definitions now. But the process of acquiring them and keeping track of versions and updating and keeping track of dependencies and whatever has been a bit bumpy. There are some community tools, one called TSD and another newer version of that called Typings, that are standalone tools that can go and download these things and lay them down in subdirectories for you. But it still has been a bit bumpy. And honestly, in order to solve some of the problems, we needed to do things in the compiler and the language and the way we resolve modules and so forth. So what we're moving towards now is that we're going to turn them all into Node packages, because it turns out that anyone using TypeScript is also using Node, because that's how they run their compiler. And Node already has a wonderful module system.
Sure.
And a wonderful package manager called NPM, and the ability to manage versions and conflicts and lay them down in a directory structure. And so we're taking the view that types are just packages, and you acquire them using NPM. And if one typings package depends on another one, then it just states that that's a dependency, and then Node can resolve all of that, or NPM can resolve all of that for you. And that's going to make it all a lot easier. But there's going to be some conventions around how you lay this out. And so right now we're working through getting all of these declarations on definitely type updated to where we want to be, and putting in the support that we need in the compiler so we can sort of solve this problem once and for all.
And I like how at NPM it already kind of just works TM, you know what I'm saying?
Right.
And so we're just going to sort of build into that infrastructure.
There's no reason to have a new package manager if there already is one, right? So people are already familiar with that. So.
Okay, so that's awesome. Now we're getting into sort of, you talked about more semantic checking, is that what you said?
Well, I talked about non-nullable types and control flow based type analysis, which are, that's been the most popular requested feature for TypeScript, and one that we haven't done so far, but one that we are now doing in TypeScript 2.0. And it's sort of an amalgam of things, but first it's, like I said, non-nullable, which is the ability to express that this particular variable cannot be null or undefined. And if it ever is, when I try to dot off of it to get a property or whatever, then I want the compiler to tell me that, whoa, watch out, this could be null.
Yeah.
You have to do something to guard against null right here. Now, up until now, TypeScript has had the view that null and undefined is in the domain of every type, which means if you declare something to be a string or a bool or a number or an object or whatever, you can always assign null or undefined to it. And that in turn means that we can never check whether something is not null or undefined, because null and undefined is a valid value of anything, right? And so the way we're doing this is that we're basically cleaving null and undefined off of all of the types. But of course, now you then need to express that they can be null somehow, right? And so the question is, how do you do that? And so one of the things we're using for that is union types. Which is, so in TypeScript, we've had union types for a long time. And union types are sort of the ability to say that this type can be either this or this or this, right? So for example, you might have a union type, say, you could say var x colon number or string, which means x can be a number or string, and then now you can say x equals 1, and you can say x equals hello, and both of those are valid. But you could not say x equals true or x equals an object. That would be an error, right? These are errors.
And that would be a compiler error.
Yeah. That would be a compiler error. Yeah. Now, imagine that what we do now is that we say, previously, null and undefined was a valid value of every type. Now we say it is not a valid value of any type. Okay? But if you want the ability to be null, then you simply union it in. So we introduced two new types called null and a type called undefined. And they each have just one value, so they're unary types. So null, the type null, has the only possible value null, and undefined has the only possible value undefined.
That's crazy.
Kind of like Boolean, but Boolean has two possible values, true and false. These only have one possible value each. And then you can just OR them in. So here you can say, oh, this is a number or null, if you see what I'm saying.
Right? Yeah, absolutely.
And so now you can say x equals 1, but you can also say x equals null.
And it's
right?
okay.
And it's okay. Now, that's all good and fine. So, and now you can sort of see how union types just
make it go away.
Well, that just, and the good news is they were already there, right? So that just makes it work, right? Now, the bad thing, however, now is that whenever you want to use this x here, if I want to say x.toString, for example, on my number, right? Well, if I did it like this, where I said x can be a number or null, and it has some value, right? Okay, let's say it was a parameter, and now I call x.toString here. Well, then we would say x could possibly be null because its type is number or null. Well, so how do you make that possibility go away?
You gotta check it.
You gotta check it. Okay, great. So you gotta write something like if x, then x.toString.
Okay.
For example, because, or maybe a little nicer, if x not equal to null, then x.toString, right? Great. This we call a type guard, and we already had that in TypeScript today, but it's somewhat limited.
Okay.
And I'll show you what some of the limitations are. But the effect of this actually is that the type checker says, oh, whenever you check whether x is not null, then we know that in this block,
This works.
x, we actually narrow the type of x to be number.
Right.
We make the null go away within this block. And we conversely know that if you're over on the else side here, well, then x over here, we actually know it's null.
Yeah.
Right? Because it must be. We can sort of reason about the types that way, right? Now, the thing about it is, though, that this traditionally, or with TypeScript as it exists today, this works with blocks when you have ifs and so forth. But often people write code where, let's say you have a function foo that takes an x colon number, right? Or null.
Right.
Okay? Now it's very common then to write sort of this bailout style that says if x equal to null, return. Or maybe if x equal to null, x equals 0. And now, here we go. Now we actually sort of need to understand how control flowed in your program. And we need to understand that the fact that you had this construct means that at this point here,
We've narrowed the type down.
x now could not possibly be null because it's been guarded in all possible code paths that could get to here.
I see.
And that's what's called control flow based type analysis.
I see.
It is where you basically pretend to execute the program and you understand all the possible ways that control could get to a given point. And if in one of those paths you see null, then it's still there. But if you can prove that it's gone away in all those paths, then you just, at that point, magically x's type narrows and null goes away. Now you can use this also to do definite assignment checking, which is the ability to check whether a variable has been assigned something before you read its value. So that's actually sort of the opposite. In cases where you declare let y colon number, for example. And then here comes a bunch of code, right? Including some ifs and some cases or whatever,
Stuff,
right? And now here, for example, you're saying y.toString. Now, this we want to be an error if
it's unassigned.
If it's unassigned. It's exactly the same analysis that you need to do. You need to pretend to execute the program and prove to yourself that a value has been assigned to y in all code paths.
I see.
So that's another feature that is part of this work. But so to do this efficiently, you need to build certain data structures, control flow graphs that tell you how control flow, and then you need to do the analysis. And of course, it becomes tricky to do this kind of stuff because let's say you have something like let y colon number or null. And then here you say y equals null. Okay? But then you have a while loop. And in here, you say while something or other, and you do stuff. But then in here, there might be an assignment of y equals a number. And now you need to be able to reason about how, because that is there, control can flow in either from the top or it can loop around
From the bottom.
And then you need to modify the type of I based on understanding all of that stuff.
So you're effectively executing almost the program?
You're not executing the program, but you are building a data structure that allows you to pretend to execute the program.
I see.
Yeah. And then you do an analysis on that data structure.
I see. So now that we're defining null and undefined, which just sounds really funny, you have to do some control flow stuff to give the compiler the ability to tell you stuff.
Well, no, you don't actually technically have to do the control flow stuff, but if you don't do it, then code like that was written like that, okay? Previously, we would say, oh, X could possibly be null here, because we would guard only in guarded blocks, not based on control flow.
I see.
And so in order for this feature to really work, or to not be a pain in the butt, we needed to do control flow type analysis as well.
And this is for helping us as programmers, as we're writing TypeScript, to know this X might be null.
Yes, really, or undefined, the other null, if you will.
And so with control flow, you have a better, it's more narrow now in terms of whether it's going to be null or not, or we're giving you a definite answer. It might be
yes,
null.
But of course you have to opt into it.
Right.
Now, and the way you opt into it is you first of all start using these annotations, right? But second, there's a new compiler switch called strict null checks that you can turn on. And only when you turn on strict null checks do we do these new things.
Okay.
So in a sense, this guy, in a nutshell, cleaves null and undefined off of all of the types, the built-in types. And then, therefore, we'll now do the analysis. Now, the thing that's interesting about this, by the way, is that it's backwards compatible in the sense that, of course, when you're compiling with strict null checks and you're using declaration files for JavaScript frameworks, ideally, all of those will get updated with null and undefined annotations as appropriate, to indicate whether this thing allows you to pass a null or whether it returns a null and so forth. But people with old code might want to use the new declaration files. Do you see what I'm saying? Mm-hmm. That actually is possible because if you're not compiling with strict null checks, then this type, number or null, is precisely the same as just saying number.
Yeah.
Because null is already in the domain of number, and so those annotations, in a sense, just automatically evaporate. And that allows you to write a declaration file that works in both worlds.
That's interesting. Because that was going to be my next question. What happens? How do you opt into this? Because obviously, you might, when TypeScript 2.0 comes out, you might put strict null checks and learn a lot about your code.
Oh, you're gonna see a sea of red,
which is good, right?
Well, yes and no, because it'll sort of guide you to where you have to put the annotations. And for fun, I've been doing it on our own compiler, which is a big code base, about 100,000 lines of code, and it's kind of like a big game of whack-a-mole. You turn it on, boom, errors everywhere, right? And then you just start with one file. You go, okay, I'm going to punch out the errors. Okay, then I say, or undefined, or null here. And then that error goes away, but then, then two other errors pop up because now this guy does not allow you to pass the null that you had here. Do you see what I'm saying? Or conversely, it returns a null that you didn't think was going to be there before, and then you stamp those out, and eventually it sort of goes through an explosion, and then it converges down.
Now, should I, as a programmer, feel like...
But I will tell you, as you do that, you learn a lot about your code. I learned a lot about a compiler code, and I learned in a bunch of places to go, wow.
How did this work?
No, this really could go bad. If this and that happens, it just so happens that it doesn't.
Yeah.
But I could see how it might. Do you know?
So as a programmer, as I'm writing TypeScript and I'm going back and I'm turning on strict null checks because I want to be more precise about my code, should I feel bad about this or null, or should I just put it in and then try to find a way to pull it out? I mean, what would be your sort of advice?
Well, I think you find that generally speaking, you want to try to be it's not whether or not it should be there. It's not one is bad and the other one isn't. It's more the fact that you should use this, and then you should either have it there or not have it there.
So you should be deliberate.
You should be deliberate about your contract, right? Right now it's fuzzy around null and undefined, and it is arguably the biggest source of errors in people's programs. So clearly it's something that's well worth checking, right?
This is awesome. Any other things in TypeScript 2 that we could look out for, or this feels like the big one, right?
Well, this is one. I mean, I think async await is something a lot of people have been waiting for too. So there are many big ones in TypeScript 2.0. But yeah, those 3 ones we've talked, or 4 ones we've talked about here are sort of the biggies. Then there's a whole slew of smaller features. Read-only modifier, for example, that allows you to tag properties in an interface or a class as being read-only, and that helps you stamp out some other errors as well. And so there's a lot of goodness.
I like how TypeScript is making us as programmers be more deliberate about what we're writing in JavaScript, right? Because with JavaScript, I mean, I make this joke, right? JavaScript is like a car where you can take the wheels off, put it on the top, and somehow it still goes, right? I mean, in its pure form. And that, to me, was a little disconcerting. It feels like TypeScript allows a precise...
Yeah, I think what you're seeing, what's happening with JavaScript is that it's really sort of slowly becoming a very grown-up and accepted language, even in the enterprise and even in big projects. It's not just a little language that sits behind some script tags in a browser and then moves cats around or whatever, right? I mean, it's actually, with Node.js, being used to write big, important, mission-critical systems. And with those, you really do want to try to be, you want to try to protect yourself from these things, because they can matter.
All right, greatly. So where can people go to sort of follow along the development cycle and to maybe put up issues or ask questions?
Sure. Well, so you can always start at typescriptlang.org, which is our website. And from there's links to everything. But obviously, all of this stuff is on our GitHub site. In fact, the nightly builds of TypeScript now already have strict null checks and control flow-based type checking. It's all in there. And lots of people have already done a lot of vetting, so it's that part of it is actually pretty ready already.
Well, awesome. Well, thanks so much for spending some time with us.
Sure.
I'm pretty excited about TypeScript 2. I'm sure you are too. Again, the great Anders Hejlsberg teaching us a little about TypeScript 2.0 coming out later on this year, he's telling us. Thanks so much for watching. We're here in Building 17. My name is Seth Juarez, Channel 9. We'll see you next time. Take care.